Okay, so this is cliff rescue with a ski patrol flavor emphasis to it. Really, we have some special environmental things that kind of go into ski patrol rescue when it comes to being on ropes. Our response times are pretty quick, so the gear that we use, we can probably get away from alpine guiding, recreational stuff, and kind of build more like go in the direction towards organized rescues. We can get to places very fast. We're familiar with the terrain, where the cliffs are, and our guests or our subjects that are stuck, well, they could be stable or unstable, as in like clinging for dear life, or just perched and like time may not be of the essence, or time may be of the essence. A couple of other characteristics: most of the cliffs that people will find themselves hung up in, they get there because of the slope. Very rarely are we just going across flat ground and then like just an arbitrarily just a 90-degree drop. It's not like Moab. So people ski down slopes and all of a sudden the canvas just disappears. And that'll play a role in edge transitions or angles. The more abrupt the angle, the more friction exists, which is a hindrance on the raise. But here it's more slanted and then it drops off. So those are some considerations. We want to do everything in our power to avoid a rope rescue scenario, whether that's coaching them back up if they have the gear. Hopefully if they threw it over the ledge, maybe we can get somebody below and hoist their gear up and then get them back up on their own power. It just depends on the quality of the snow, the boot pack conditions, their comfort level, exposure hazards, all that. Our last resort is some sort of rope system. Really what cliff rescue is, it's a pickoff. You could say it's a mid-face pickoff. That's a universally known thing in just the rope rescue realm. And there are a bunch of subcategories. Here we're doing something called team-based, which means we aren't sending a rescuer solo to be a hero on a rappel and pick somebody off. We're lowering a rescuer down, and then we're going to continue to lower down with a package or haul up, depending on what we want to do. So it's team-based, and it's unsupported, meaning our subject is not on a pre-existing rope system. So team-based unsupported pickoffs is what this is. When we get on scene, first thing we want to do is identify our fall line, because we can't change that. Like, that's going to dictate where we put our anchors to operate. And so Kyle is the fall line right there. We're going to assume that he went over the edge, and this is our path. Some considerations on where we set up our anchors. Well, we don't want to get too close to the edge. Granted, if we're doing a lower, we could probably go closer, but if we're going to haul somebody back up, we need some sort of haul field. So we want to set our anchors back away on this slope, gives us some space to actually put our throw for mechanical advantage. And if you look back, if we take this camera and we look, there's a big tree here, and then there's a big tree directly back, and they aren't quite directly in line, but they're pretty close. Some considerations when we build rope systems: this is a two-rope system by default. We always have some redundancy. So whether that's a single main and a dedicated belay line, or a dual capability two-tension system, however you want to call it and what mode of operation you want to do, it's fine. But one thing is kind of key is how far apart our anchors are in relation to our alignment or our fall line. We want to get everything as close directly down as possible. Sometimes that's not possible. Here we're pretty close with the smaller diameter tree that's further back, and then a larger diameter tree that's a little bit off to the side but relatively in line. So our ropes are going to kind of V a little bit, and that's okay. If the further out they are on a lower, okay, it might not be critical, but on a raise it's going to be really tough to be efficient on a haul. Plus we have to consider the edge, because if one line fails, what's the consequence? What's the pendulum effect? Because if one line fails and one line is over here, we pendulum swing, we have to be really cognizant of what's happening on the edge. If there's a sharp rock there, that can just cut the rope. So that's why lining up your rope system into the alignment line is really important for us. Okay, let's go back and look at our anchors. So behind us, smaller tree, probably weaker than this more robust tree that's closer to the edge. And so that may play into how we rig for a haul system. But let's just go up and start rigging our anchors. Because this tree is smaller diameter, let's talk about like what we're looking for. Well, we want to make sure it's live. So I see some live branches up higher, and I want to make sure that it's at least, maybe, I don't know, you could argue what type of tree it is, 6, 5, 7, 8 inches, whatever. Experience and judgment will dictate how good you feel about this. People always say, oh, you want to build your anchors really low to the tree at the base because that's going to minimize the torque effect, and that's true, it does. But if you're fairly confident and the integrity of the tree, you want to make a compromise. And the compromise I'm going to make is I'm going to rig it a little bit higher because I want to operate my devices off the snow. And when they go slack, I don't want all my stuff to drop in the snow, like my ID. I don't want snow to get caked in there. Okay, so we have these manufactured anchor slings that are really fast, really quick, but they do have their limitations. Like on bigger trees, like maybe the one below that we're about to do, maybe an anchor strap is not gonna work. It's a possibility that it's not gonna work, but here it'll work just fine. So, single point anchor with a sling or a strap, and this is adjustable. It's intuitive. Most people will just do something like this and call it good, but this is a load sharing single point anchor, and the argument I have on this is why limit yourself to load sharing where if there's enough abrasion, one strand will go slack if your resultant force changes slightly. Let's make it load distributing and have all the benefits and none of the downsides. So here, like this strap is extended out. Like this is real estate that's precious to me. I'd rather operate my device close to the tree. And so just sizing this up, I'm going to shorten the strap pretty tight. And I'm going to take advantage of like the tree features itself, and like there's a little perch here, a little snag. I can just use that to kind of help support. So I'm going to get this thing pretty close. And instead of connecting my ID here, I'm going to rotate this around. Now I've created a self-equalizing, load distributing, self-equalizing anchor system. So single point anchors, this is kind of your best practice. Do you have to do it? No, but this is all the finer points, all the minutia that will make you a better critical thinker on an actual rescue. So we have one anchor set here. We're going to rig our line, our ID for one. It's dual capability, 2 tension system. We're going to hook a rescuer in and lower the rescuer to the guest. When we lower our rescuers, we want them to be as streamlined as possible. So we don't want them to go down with their own skis. We're going to leave the skis and the poles up here. Let's go to the bigger tree. The classic single point anchor with webbing is your wrap 3 pull 2. So I have plenty of webbing to make this work. I start by tying my skeleton water knot, and I'm going to pin it right here. And again, I want some elevation off the surface, but I don't want to be super high, right? I want this compromise. So here we go. So this is my reference point. That's 1 wrap. That's 2. And we do wrap 3 pull 2s because that guarantees that our webbing is stronger than our rope system. If you want to geek out and talk about braking strengths, tensile braking strengths, that's kind of why they do this. So that's 3 wraps right there. Notice how everything is sucked up tight. What I'm going to do is I'm going to find my knot, my placeholder, and I'm going to back off a little bit, and I'm just going to fold the rest of the webbing into a bite. I don't want to, like, this is extra stuff I don't need, and if I do a wrap 3 pull 2, by tying the end of this, my anchor's way out here, and then it drops into the snow, and it gets clogged up. So this is just a clean way to do this, where I fold it into a bite where I want to actually finish my knot with it. And then it's just a regular water knot. This is called the frost variation of a water knot. And I just want enough bite to actually be able to complete the knot. So that should be more than enough right there. So single point load distributing anchor. And now we do our classic pull 2 strands and get that knot flat up against the tree. Okay. Now if you look at the catenary angle here, 30 to 90 degrees is ideal. That's 90 degrees or less. So I'm pretty comfortable and happy with that. This is excess webbing that I don't need, so that can just flake out behind. And now I clip my device here and it stays here and I don't lose it in the snow. Dual capability 2 tension lowering system through a pair of IDs. The operators are gonna try and match each other's speed. And we're ready for down at your pace. So whenever. And let's focus in. I'll take the camera temporarily. Let's focus in. We're going to start by taking before we actually execute. And we're going to assume that we've already packaged the patient and we're going down. So we've lowered the rescuer down, they made the connections, and we're going to keep going down. We always start in high friction mode, which is back clipping. Down. And all we have to do is say down on the system. You could argue like, well, which one's the belay? Well, they're both the belays and they're both the working line at the same time. If you look at our angles, that's okay on a lower. We can get away with that. We aren't spread too far out. So they're matching each other's speed. If the friction is too high, we have options. We can come out, but we don't want to be oriented in this direction with the handle open because then we lose the friction. What gives us friction through the ID is the bend, the back bend. So Crop is just gonna like try to gauge where that is. And right here, that's kind of the limit. If the friction horn is too much, we can always back clip on a carabiner, and that might provide for less friction, like that magical sweet spot. Okay, so there are numerous ways to haul a rescue package in an austere environment. It's not as clean, cut, and dry out in this kind of environment as it is like in an urban, industrial environment where you have options for flat ground pulling. So we lowered on a 2-rope system through IDs. IDs are favorable. People like them because they have an auto-locking feature to them. But the term ID stands for industrial descender. Descender adds lots of friction. So they're great descenders. They're terrible when you want to actually haul efficiently. But if you can get away with it without having to change what you have on your anchors from the lower, then stick with it. So yeah, you should consider starting by leaving your IDs in place and then just rigging a simple 3-to-1 Z-rig. This setup here is a dual capability 2-tension haul system. So go ahead and haul both. And we're gonna try to hand over hand haul this. We don't want any heave ho. Okay, stop. If it's a full rescue package and there's a lot of friction, sometimes this doesn't work out very well. In theory, it works out if both haulers are hand over handing at the same time, at the same speed. They're truly splitting the load or the force of the load in half. Oftentimes what happens is that's not the case. One person is hauling the entire load while the other person is not, and vice versa, so there's overlap. It helps if both these haul systems on each one of these lines is directly in line, which would give both rescuers the ability to grab both lines at the same time and truly haul on a 50-50. The further out these are, the less practical that becomes. And we have other ways of kind of hauling. This is your baseline. So the default should just be, okay, don't touch your devices on the anchors, leave the IDs in place, and just rig a simple 3-to-1 Z-rig. That's in theory. In reality, this is actually, best case scenario, you're probably getting 2-to-1 out of this. It's not very ergonomic to have to haul uphill, and so some people will put a final change of direction on their system at the anchor. So let's go up to the anchor. So for better hauling ergonomics, let's say Crop wants to use his body weight and lean back into it and take advantage of the slope. So that's a pro. The downside to it is that when we route, go ahead and route or change the direction here. When we route or change the direction through a pulley, we do lose some mechanical advantage, hauling efficiency. So when we were a 2-to-1 with the ID, that adds a lot of friction in actuality. In theory, it's a 3-to-1. Now it's a 3-to-1 with a final change of direction in theory, but in actuality, it's probably closer to 1.5 on this. But if Crop can overcome that loss by making it easy for him to just take his body weight down the slope and just haul down and pull down, that's a plus. And then our other operator can do that too. So let's zoom up here. Let's focus in on what we have here. In our kits, we don't have like a whole lot of stuff. So really collectively, like between the two systems, we have 4 pulleys total. If somebody were to do this doing a final redirect with a carabiner and having your ID still intact defeats the whole point of creating a mechanical advantage system. You're down to like 1-to-1. You might as well just haul straight on a line. You take a 50% hit in your hauling efficiency with a carabiner. So if you're gear limited, put your most efficient things closest to the haul input. If you only had 1 pulley, then put the 1 pulley here and just use the carabiner down at the traveling, where the traveling pulley is on that Z-rig. Just little tips to try to get your biggest bang for your buck. Okay, so now we're ready to haul downhill. Cool. All right, Skid, you ready to haul downhill? All right. Okay, slow haul, real slow. Okay, so now both of our operators are now walking downhill, taking advantage of gravity to help raise our package. Okay, stop. So this is a viable option. One thing I didn't cover was what is our throw, what's our haul field. Our throw is how much distance we can go before we reset our system. And so if we can take advantage of the slope and push our mechanical advantage as far to the edge as we're comfortable with doing, we're going to do that. We don't want to risk our rescuers falling, but we want to maximize that throw. And then the haul field is just where we physically can actually like move. Sometimes they're one and the same and sometimes they're not. That is a, in theory, 3-to-1 simple with a final change of direction on each set. In reality, it's more like 1.5 to 1. But if this is all that's needed and you can get away with that, great. We're going to switch it up a little bit again, and we're going to go down the path of maybe our load is even higher, and they're pretty far down, and our edge transition is very abrupt. The more abrupt the edge transition, the more friction that we have to overcome significantly. So we're going to re-rig it, and we're going to try to maximize like the best we can possibly do with the gear we have. So we are no longer going to be doing a 2-tension haul system. We're going to change modes of operation, and we're going to go with a single dedicated haul line and a single independent belay line. And so what that's going to look like, since I'm switching modes that way, this black line, the anchor is further back and the diameter of the tree is smaller, so this anchor is probably weaker. So I want my main hauling system to be on the weaker of the two anchors. I also want my main hauling system to have the greatest throw, and that's what this black line is on. What I'm going to deem as our belay line on this bigger tree right here, where the red is, that's my belay. The belay needs to be as strong or stronger than your main working system. So that's why I'm going to designate that as the belay. Plus it's closer to the edge, so I don't have to worry about space to haul. We stop operation, and this ID is just going to trail the haul. And so here we're just going to make sure that we lock off. We're in high friction mode. And then skid, we're just going to de-rig the mechanical advantage in this all together. And then I'm going to commandeer all these pulleys and give them to the black line operator. And this is pretty easy to convert on the fly because we have these IDs. Again, IDs are great because they're auto-locking progress capture devices. So we are going to auto-lock and progress capture on our red. Since we designated that the red line with that's closer to the edge, that has the girthier tree that's stronger, is the dedicated belay line. It's gone taut, it's locked off. Give some weight. There you go, so it's not going anywhere. We're going to lower out on the ID. We can rig something around the ID, but filming that is a little convoluted, so I'm completely slack on my ID, and all the load is being held on the belay line temporarily. We're okay with that because we're in a static state and nothing is moving. So again, this is an option, but it's not the baseline. The baseline is just rig a simple 3-to-1 Z rig with the IDs, call it good. If you need more, then we're gonna have to start thinking outside the box here. So the absolute best efficiency on a haul that we can get with the pulleys we have, we're gonna get rid of this 32% efficient descent control device, or descender, and we're just gonna use all pulleys. So we need a progress capture. We're changing everything to all pulleys, which is something we did in the past traditionally, and it's still relevant. If we can put all high efficiency pulleys in our system, that's just going to maximize our hauling efficiency. So 3-wrap progress capture. I'm going to use the same carabiner. I'm going to put this in, the prusik in a little low, and then put the carabiner, or put the pulley on top of it. So prusik in first, followed by the carabiner. Or sorry, followed by the pulley with the rug. So goes up. Okay, directly to the load, and now I'm going to suck this up and get this taut. Okay, so our prusik engages. For all intents and purposes, we're back on a 2-rope system. I have a high efficiency pulley as a change of direction. And what I'm going to do now is build my 3-to-1 here, my standard classic 3-to-1 Z rig. And actually I've already done that with this prusik right here.
Here's one I prepared earlier.
Okay, standard Z rig, simple 3-to-1 mechanical advantage. Okay. So, Z-rig. Instead of putting another pulley here for a 3-to-1 with a final change of direction, I'm going to maximize, I'm going to make all my pulleys move. and this is going to give me even more mechanical advantage. So I'm going to extend this out just a little bit so I can put in another rope grab right here. So another prusik. My 3-to-1, that would be a final change of direction here if this were at the anchor, is no longer at the anchor. It's on the back end of the line, and I'm bringing it down. I have one extra pulley. I could put it here, but all that's going to do is I'd have to haul back uphill. So I still want to haul downhill and use my body weight and capitalize on that. But now I don't take a hit on that final change of direction. And this is called a complex 5-to-1 mechanical advantage. The only real downside to this is that if I extend this all the way out to my max throw, these things are going to travel in opposite directions and collapse together at the exact midpoint of my throw. So I need to reset the system more, but my efficiency on the haul is that much greater. So it requires props to hold this in place, and I'm going to extend this all the way out to the entire distance of my throw. So the approximate midpoint of my throw is right in here. And now I'm going to haul it downhill on a 5-to-1 complex. And as I do this, the belay is just taking through the ID and capturing progress. And I said that, yeah, it's not, this is a theoretical mechanical advantage, 5-to-1. In all actuality, practicality, it's more like a 3.5. So again, this is probably the absolute best we can do with the gear we have. And I collapse in 2-block here. We're captured there. And then the progress capture up at our pulley. Let's set that. So we lock off. All right, Sam. So now we're locked off here. Again, it was easier for me to haul downhill with higher mechanical advantage, but I lost half my throw, which is, okay, you can't have your cake and eat it too, but this is an option. Again, not your baseline. Stick with the 3-to-1s with the IDs. And this, now one person has to go down this way, reset, one person has to reset that way, and then we cycle it over again. Complex 5-to-1. Those are options. Simple 3-to-1 Z-rig, simple 3-to-1 Z-rig with a final change of direction. If that's not working, switch modes from 2-tension hull to single main, single belay. The single main is going to be even more. We can go 5-to-1.